Hello YouTube and welcome to What the Math. In this video we're going to be talking about Pluto. Okay, not really. We're going to be talking about dwarf planets and why Pluto is no longer a planet, and actually we're going to decide, is it possible that we can actually change this? Can this ever be reversed? Can Pluto still become the 9th planet like it used to be for, what, 70 years-ish? 76 years, I think. It's a dialogue we're gonna have, and we're gonna do some fun stuff in Universe Sandbox too, and hopefully you enjoyed this video. Anyway, let's start. So what is Pluto? Why is it not a planet? And I think to answer this question we have to actually zoom out and look at what basically defines a planet. So right here, if we actually go toward the sun, toward the center of the sun, we'll notice that we have the 8 classical planets close to it. So there's Mercury, there is Earth, Mars, Venus. Then we have Jupiter. We're gonna ignore these two. We'll talk about these two series in Vesta in the next video. Jupiter, Saturn. Then we have Uranus and Neptune. So these are the 8 classical planets. And if you look at them, there's one thing that might strike you right off the bat, is that they all have a very stable, very kind of almost circular, and also very flat orbit. So that was actually one of the things that people wanted to use as a definition of a planet, so that you have to have a very stable, very circular orbit. But that's not just it. The other thing you'll notice is that there's really nothing in the vicinity of their orbit. So Neptune is all by himself here. I mean, obviously Neptune has satellites orbiting around him, it has its own moons, but there's really nothing else here, so it's relatively empty. And of course, if you zoom in and you look at them closely, you notice that they're all kind of, spherical. They're large enough to be spheres. So basically, that's the nutshell of a definition. So definition, according to the Astronomical Union, is that, well, to be a planet, and we're going to be using Saturn just as an example. Oh no, the Saturn has no rings. That's not good. Let's use Jupiter then. Hello Jupiter. Alright, so why are you a planet? Well, you're a planet because first of all, you're orbiting the sun. So yes, you're orbiting the sun, like so many other objects here, which means that, we could have tons and tons of planets. Number 2 definition is that you have a sufficient mass to become spherical. So if you have a large enough mass, you'll be a sphere. If you don't, you will remain as an asteroid. So here's a randomly added asteroid I just added. That, as you can see, it's not a sphere. If you don't have enough mass, it will actually remain as a non-spherical object. Now, this roundness that it's called, it's actually there is a definition for it as well. So some scientists suggested that it has to have a mass of at least 5 times 10 to the power of 20 kilograms. If you look at this object, it only has 1.62. I don't know if you can see this, 1.62 times 10 to the power of 17. So if it actually had, I'll just say 5, I'm going to change this a little bit. Let's just change this first. This is going to be 20. And you can already see it started to get that spherical shape. And this has to be at least 5. So at this point, there we go. So now it looks more like a sphere, and look at that. It even has atmosphere. Holy cow, it's growing. Oh my god, it's scary. It's so beautiful. So now this would be considered to be planet-like, but not really a planet yet. So it has to have a certain mass, but this mass actually depends on what's inside it as well. So if it has more ice, it can, or actually if it's entirely ice, it can even be smaller to reach the sphericalness. Objects that are approximately 200 kilometers and are all ice can also become spheres. So it's a bit of a tricky definition when it comes to roundness. What does it what do you have to have? What does it have to be round? But this is actually turned out to be a very beautiful looking moon of Saturn. Alright, so that was the second definition. So basically roundness and also orbit around the sun. But then there's a third thing that makes you a planet. And this is actually the reason why Pluto is not a planet anymore. And specifically, we're referring to being the only major object in the orbit around the sun. So to explain what this means, I'm going to have to do 2 things. First of all, I have to enable orbits, just to show you what it looks like. And let's look at Mercury this time. So if you look at Mercury, it is actually the smallest planet, and it is a planet for one reason only. Because if you look at its orbital path, right here, there's nothing else in its orbital path. It is the only object. It doesn't even have any moons. If you look at Venus, same thing. It's the only object that is large enough, spherical enough in this particular orbit. Now, if you go back to Pluto, I don't even know where it is anymore, because look at how many orbits there are here. Look at how many different objects. Oh, here it is. look at how many different objects are orbiting in this area. So yes, Pluto is spherical. It is large enough to be a sphere. And yes, it is orbiting around the sun, but it's not the only object in here. There's so many other objects that are orbiting in the same vicinity and with a similar kind of a structure. Now, Pluto is actually the biggest of these so-called dwarf planets, as they're now known, but a lot of them are very similar to Pluto, so we're actually going to take a look at some of them. There's a really awesome simulation that this game has, and it's in the main, so you have to open all, and then you have to go down in the main simulation here. We're actually going to take a look at two things. First, let's take a look at the solar system with all possible dwarf planets. So this is going to be really interesting because, yeah, there we go. It is so slow and it is so many of them that my computer is having trouble reading this. So I'm going to actually get rid of planets just to give you an idea. No, we're going to keep Mercury, and then we're going to get rid of all of these other planets that we don't need. So Venus and Earth, I'm sorry, you have to go, and everyone else as well. Okay, so here we go. I've only left Mercury because I just wanted to give you an idea of the sizes and proportions. So let me just zoom out first. So there's no more planets left. It's only dwarf planets. And look at how many there are that we already found. The number in front of them indicates the date when they were discovered. So there's one from 2010, there's one from 2007, and most of them were discovered after the year 2000, which is basically when the whole discussion about Pluto started, because we weren't really sure what to do with it. Is Pluto really a planet? And now we know it's not, because once again, so I'm gonna disable this. Here we go. This is how many different dwarf planets or objects that could be considered to be dwarf planets there are. So if all of them had to become planets, you know what? If you ever take astronomy class, it will be probably the most difficult class ever, because you have to memorize all of them. But instead, the Astronomical Union decided that it's much easier if we just keep 8 classical planets and reclassify everything else as something else. Now, the reason why I decided to turn this simulation on and remove the planets is for this reason right here. I'm going to enable chart, and this will show you, so I'm going to just move a little bit to the right. What this does is it compares sizes. Compares sizes of different objects, and I need to just move a little bit to the right until we see Mercury. Okay, so here we go. So this is the Sun, this right here is Mercury, and I just realized that I'm missing the most important of the dwarf planets, Pluto. For some reason it didn't show up here, but the next one is Eris, and as you can see, size-wise, it's actually very similar to Pluto. I'm gonna keep moving, and you'll notice that as we progress, the sizes don't actually decrease that much. So right here we have another named dwarf planet called Makemake. Then there is Quasar, sorry, Haumea, and so on. And Sedna is here as well. This is actually an inner dwarf planet. And size-wise, they don't actually decrease that much. So there's quite a lot of them that have a very similar size and mass as well. So as I keep going, and there's a lot of them, there's like hundreds of them that we've already discovered, and there's going to be even more as the time progresses. And so yeah, it just keeps going. And I mean, I'm going to have to do this for a few minutes before we even reach the end. So instead, let's take a look at something else. Let's take a look at this normal simulation of a solar system that has just the main objects, main dwarf planets, main planets, and also obviously the Sun. So I'm gonna once again remove the planets so that they don't actually interfere with us. But this time we only have the main ones, the major ones, the biggest ones, the ones that have names and so on. So let's take a look at the chart again and compare the sizes. And this is a lot faster as well, so I kind of like this more. So these are the major, once again, this is Mercury, and these are the major dwarf planets. So we have, right here we have Pluto and Eris, which are actually very similar in size. We've only recently discovered that Pluto is just a little bit larger, a few kilometers larger than Eris. And Eris is the dwarf planet we'll probably never really reach, at least not for the next few hundreds of years, because it's really, really far and it's kind of difficult to get there. And here's actually a better view. Look at how similar they are. They're very similar in size. Obviously, as we go further away, they'll get smaller and smaller. But for the most part, most of them are around 500 kilometers in the radius, maybe even a little bit more. And what this means is that there's just too many objects out there that are planet-like for us to consider planets. And so now we actually have a new definition, and this is actually the definition that all of these objects meet, and this is called a dwarf planet, which is basically a celestial body. It's a body that orbits around the Sun. It has a sufficient mass to become spherical, like all of these guys are spherical, And there's actually a word for this, it's called a hydrostatic equilibrium. Basically, you become almost completely spherical. But the important part about dwarf planets is that they have not become the only objects in their orbit. So here, and for that we have to actually look at the orbital paths again. Here you can see that there's so many of them in a very similar kind of a orbital area. Even though it's not the same orbit, it is a very similar orbital path. So these are actually called trans-Neptunian objects. And in their case, there's just a lot of them. And so for that reason, they have to be classified as dwarf planets. So even if one of them was large enough to be like Earth-like or even Jupiter-like, it would still be called a dwarf planet. And another interesting fact about all of these dwarf planets together, and I'm gonna go back to the chart here, is that they actually are a lot less massive and a lot less small than even our moon. So I put Mercury here, but let's actually just put moon in there as well, just so that we get a kind of a comparison. I'm gonna add moon to Mercury. So right here we're gonna have moon. As you can see, it's actually a relatively similar size to Mercury, and it's going to orbit around Mercury. And let's go back to the chart and now compare them. So here's the moon and here's the rest of these dwarf planets. And the thing is, if we were to combine all of the dwarf planets together, if we actually were to add them up, and I was trying to do that before, but it's actually relatively challenging because they keep flying away from each other and then you have to catch them and try to re-add them again. But anyway, if you were to add their masses together, it would still be, they would still be less massive than the moon. And I think maybe in a future video we're gonna try that. We're gonna just, spend a few hours trying to combine all of the dwarf planets together, just so I can show you that the mass of the moon is actually still about 3 times larger than the mass of all of these dwarf planets together, which is actually really interesting because they're not as big and not as massive as you think. And to be more exact, in 2008, another definition has been actually added to these particular dwarf planets, and these are now known as Plutoids. So basically, if you're an object in a trans-Neptunian orbit and you're kind of a planet-like, but there's other objects in the same orbit as you, you're known as a Plutoid, which is one of the dwarf planets. The reason why they're not all called dwarf planets is because we also have something called Ceres, and I'm not sure if it shows up here. There's Ceres and okay, maybe, oh, here it is, Ceres and also and Vesta. There you go, Ceres and Vesta. We'll talk about these in the next video, but these are not Plutoids. They're dwarf planets, but they're not Plutoids. Anyway, let's have a little bit of fun. Let's actually go back here on Earth, and what we're gonna do is, just to give you another comparison of size and mass, I'm gonna actually generate a system around Earth that will involve, well, first of all, we need to have a moon, because the moon is missing. Let's put a moon at its actual distance of approximately 300,000 kilometers away from Earth, close enough. So here's our moon, but also let's actually add a few dwarf planets in between the moon and the Earth, and let's just see what happens. We're actually gonna observe the simulation and, make your predictions. What do you think will happen? So we're gonna go right here, not planets, minor objects. There's actually all the main ones listed right here, or most of the main ones. These are the ones that have names. And I'm actually gonna add Ceres as well, just for fun. So we're gonna have Pluto in the middle right here, and we're gonna have Chariklo, Ceres, Pallas, maybe between them, Sedna, Eris, and Makemake. So only a few. Oh, look at that. Pluto has already decided to get an orbit going with Chariklo. So let's actually just run this simulation and let's see what happens if we advance time. And essentially, what this actually simulates is early solar system, because there are theories that initially when Earth was just formed, it actually had more than one moon. It actually had several moons, and some of them may have been large enough or close enough in size and mass to the moon, but something must have happened, something must have occurred. So let's just actually have these dwarf planets orbiting here, and let's see what happens. And just to give you a comparison of size as well, let's go back here again. I'm going to ignore Jupiter, I'm going to ignore everything else, and look at the size comparison. So this is Venus, this is Earth, this is Mars, and right here we have Mercury, Moon, and what is this? Why? Oh, okay, Pluto has fire because I think something smashed into it already. Ah, interesting. We missed that. We missed the collision. And so yeah, these are the dwarf planets orbiting around Earth right now. And Pluto's surface is covered in debris because there was a collision with something. I don't know what, but something smacked into it. So I'm going to look at it from kind of a top perspective here and accelerate time just to see what occurs and what happens. So just watch everything. So moon is right here, and this is probably the more important one of the bunch. And just watch what happens. So this is only a few days after we added them. And already the orbits are quite unstable. You can see they're shifting around, they're moving around a lot. With the moon actually having probably the most stable orbit, and something just smacked into the moon. We can actually look at its surface. There's debris flying everywhere, something collided with it. And this is really why the moon has so many craters on it, because it had a lot of collisions early on. A lot of things smacked into it, a lot of things collided with it. But because of its mass and because of its size, it really... Well, there's two things happening. One is that it didn't really budge a lot. Its orbit stayed quite stable because it's very large, it's very massive. And the other thing is that it sort of played as a kind of a defender of Earth. So a lot of things are more likely to collide with the moon than they are with Earth. And you'll see that happening here because Earth is still fine. See, nothing actually smacked into it. It's still kind of okay. It may have had a small asteroid fall on it, but for the most part, it's still fine. The fragments right there that are flying away, those are leftovers of one of the dwarf planets. But I'm gonna just accelerate time a little bit more just so we see the evolution of this system. So you see the orbit of Makemake just shifted because its mass was not large enough to maintain an orbit, and something that was more massive approached it. Pluto is the same. Look at that. Pluto has changed its orbit, making it very, very elliptical, just like in real life, and something just flew away. That was Pallas. And all we see is that the moon's orbit is quite stable, but all of the other orbits are shifting around, they're moving around, they're changing from being very elliptical to just basically literally flying out of Earth. Oh, look at that, something is really close to Earth right now. That is something I didn't really expect. It actually has not happened before, but now Pallas, which is actually a relatively large dwarf planet, is actually in a quite stable circular, almost close to circular orbit around Earth. Now this is something I haven't actually expected to happen, but let's see if it stays that way. And we just lost another dwarf planet. Makemake is gone. It came close to the moon, and the moon actually changed its orbit dramatically, making it fly out of our Earth system. So currently we have 3 dwarf planets and 1 moon. So moon is still there, it's still in a very stable circular orbit around Earth. Then we have Pallas very close to us, and something just changed orbits again. Eris, that was Eris. And Eris and Pluto are still around as well, but right here, there we go. Eris just collided with the moon. So Eris is gone. Let's look at the moon, because Eris is actually a very large object, so I'm kind of curious. Okay, so the moon is on fire. Because Eris is so large and heavy, or I guess massive, it caused the moon to really heat up. It's actually, what's the temperature here right now? The temperature is 985 degrees, so it's close to melting point, but not there yet. Let's actually take a closer look at it. Look at how beautiful it become. It's become really, really beautiful. Gorgeous molten moon, but you can still kind of see the features that the moon is known for. But yeah, we just lost another one, and once again, it smacked into the moon, not Earth, so Earth is still quite safe. And this is a very important feature of our satellite. So moon is very important for Earth to kind of be the defender. It protects us from various collisions. It's actually the reason why there hasn't been more extinctions on Earth, and it's all due to the moon's very stable, almost circular orbit around Earth. And even though Eris is actually one of the heaviest dwarf planets, its collision didn't really change the orbital path of the moon. Even though it shows as white here, it's still orbiting around Earth. It's just not really showing that it's around Earth. So maybe if I remove the orbits and re-add them again, no, it doesn't show. But you can see here that it's still kind of orbiting around Earth in a very circular pathway. Now there's still some fragments here, and these are a little bit more dangerous for our planet, because these may possibly smack into Earth. And what you're observing right now, this is actually called gravitational assist. So this fragment has increased its speed because it approached the moon from the back. So because of that, its speed has been increased, and now its orbit is a lot larger than it used to be. I'm gonna zoom in back to Earth here, and we're just going to accelerate time again and see if anything else happens. I'm actually kind of curious if one of these days either Pluto or something else disappears and goes out of this orbital path. Now the fragment number 2, which I was really worried about, is because of the moon again and because of the other specifically Pluto and Pallas orbiting around us in a kind of a circular path as well. Fragment number 2 is also, look at that, it's escaping into the outer orbit. And it's probably not going to smack into Earth. So right now, nothing really affected Earth. And as I continue running the simulation, what I'm witnessing here is that, well, everything seems to have stabilized. So we have moon going in circles. We have, I'm just going to slow this down a little bit. We have Pallas right here around Earth in a very stable circular orbit. We have Pluto in a somewhat circular orbit around Earth as well. And we have the moon. Now, this will probably not change anymore because their orbits have stabilized, so they're very likely to just stay here. And this is actually one of the first times I've witnessed this. Normally what happens is, just like with the other dwarf planets, most of them end up flying into the outer system. So Sedna, like Sedna right here, see Sedna has actually escaped and has, it still has an orbit around the sun, but it has escaped into its own orbit. And the same for Makemake and the other dwarf planets that we used to have. And so basically they kind of ran off. They disappeared from our orbital path, they disappeared from our orbital area, and now they have their own little lives. Whereas what we have around Earth is that we actually somehow managed to acquire 3 satellites. And essentially this is how a lot of the other larger planets, such as for example Jupiter, Uranus, Neptune and Saturn, have acquired so many different satellites of their own. Basically they had a lot more before. Many of them flew into the outer solar system, and actually many of them have probably even become those dwarf planets that we have today. And those that remained actually maintained a very stable orbit around the main planet. But here's the thing, there's one thing I have to mention before we finish this simulation, is that because now Earth is not the only object orbiting around Sun in that particular vicinity, so there's also Makemake, Sedna, and oh, is that it? Yeah, okay, maybe there's only 2, Makemake and Sedna. And because their mass is relatively large and they're also spherical, Earth technically may not be a planet anymore. So in this particular simulation, I think I just turned Earth into a very, very large dwarf planet. And at least that's according to the definition from 2006 by the International Astronomical Union, also known as IAU. So it's very possible that this is now a very large dwarf planet because of the other objects in the same orbital path around Sun, which specifically I'm referring to Makemake and Sedna. Anyway, so let's end the simulation with something a little bit more dramatic and explosive. And by dramatic and explosive, I of course mean the collision of Pluto with Earth, and we're going to observe that from Pallas. So I'm going to stop this, I'm going to pause this for a second, make the velocity of Pluto, so right here I'm going to make the relative velocity of Pluto to Earth 0, and this should actually, theoretically at least, make it fall into our planet. So we're going to observe all this from beautiful Pallas, which actually is right here. So let's see what happens. Is this going to cause a collision? So moon is right there and it's still gorgeous. Look at how beautiful it is because it's actually still burning from that collision with Eris. So this is a very interesting universe we have. The universe Sandbox has created a very unusual, very interesting universe. And Pluto, as you can see, is slowly approaching us. Actually not so slow anymore, it's actually moving really fast. And it is going to, hopefully, even though it sounds horrible, but hopefully collide with Earth. So let's actually watch that. Or possibly even Pallas as well. Nope, Earth. There we go. Oh my god, I just destroyed the humanity and everything else on Earth. So this will very likely cause the final extinction of everything. So there's no way anything can survive this particular explosion. Because, look at that, Earth is about to turn into a molten ball of lava. And this is gorgeous. This is super beautiful. All we'll have after a few years is, well, basically, yeah, we'll have just a molten ball of lava that will eventually harden again. And if there's any water left, maybe we'll have a kind of a, and you can kind of still tell the continents apart. There's still a bit of a outline of the continents from the other side, but this side is totally covered in molten lava. So this is actually one of the more beautiful simulations I've witnessed so far. And if we actually zoom in on Earth now, we'll see that all the oceans are gone because the temperature of Earth is currently 1400 degrees Kelvin, which is approximately 1000 degrees Celsius. Not sure how much it is in Fahrenheit, I'll have to do some math. But yeah, so basically that is what would happen if Pluto collided with Earth. Let's actually accelerate this and make this advance a little bit. I believe it's going to start cooling down now because it didn't actually affect Earth that much. But we may not ever really have oceans on Earth because I think this explosion probably evaporated all of the water which possibly escaped into the outer atmosphere. And just for fun, I'm actually going to advance time until the temperature cools down, and I think the simulation in this game will actually show the oceans, but in real life it's very likely that water would be gone. And right here you can see the temperature increasing quite quickly. At some point we'll actually not see the fire anymore, and even though the Earth is sort of radiating right now, it's going to become just a very hot rock soon. And here we go. It's now a very large, very hot rock that basically has no water, no liquid on its surface. It's basically just a big rock. Interestingly, if you look at the night side now, there's no more lights. It actually does simulate the extinction because this used to have city lights everywhere, and those city lights are gone. They're no longer there because we literally just destroyed life on Earth as we know it. And look at the size of those craters, they're just humongous. So about 10 years later, the Earth is still at 840 Kelvin, which is about 500-ish Celsius, or 600-ish Celsius, and it's still just a very dead-looking planet, so there's still nothing on it, no water, no liquid of any kind. All you see is ocean floor, and obviously there's no night sky at all. Okay, so this is, I kind of cheated a little bit, I decreased the temperature manually because it wasn't doing it fast enough, but this is what the new Earth would look like with clouds and water on it. So we have a very large lake in the middle of South America. There's a huge piece of Mexico and North America missing. There's a very large lake in here as well. I don't even know what this is anymore. I think this is where Florida used to be. Canada also seems to have some kind of a new water body. And now if we look at this is actually really interesting. So this is where New Zealand was, and now there's all these new kind of continental islands everywhere. The water here is missing, and Eurasia, specifically Europe and Asia, are totally different. There's just such a different new look to them. So Russia has a huge sea, India has a new sea, and so does China. Africa is also very different because Southern Africa was actually also destroyed. And so yeah, this is what a new Earth would look like if we had a collision with Pluto and if it actually hit the Eurasian continent. Anyway, so I'm gonna pause it here. Hopefully you enjoyed this video. Hopefully now you know a little bit more about why Pluto is not a planet and what dwarf planets are all about. And hopefully now you also know what happens if you collide Pluto with Earth. Anyway, thank you for watching, please subscribe, and if you enjoyed this video, check out some of the other Universe Sandbox 2 videos that I posted. The link is in the description and also right here on the screen. Thank you guys, and game you later. Bye bye.